Alright, looking at the worksheet A for chapter 12 on vectors, starting off with number 2. So some given information here. We have the magnitude of vector OA is 3. We got the magnitude of vector OB is 5. Their dot product is 7. And so the first part's asking us for the measure of angle AOB. So a couple things on this. One thing is, first of all, recognize that anytime you see the absolute value brackets, those are not absolute value. They are magnitude. So those mean magnitude. We also have some good formulas to help us out with this one. I also have a vector notes summary page available for you on the website that you can look at as well. So let me go to those really quick. So this one's talking about a measure between two vectors. So the measure of the angle between those two vectors is what we would call angle AOB. So if you look at your formula packet, we got a few things in here that would help you for this. So again, it starts off with the magnitude. So that's what those brackets are telling you is magnitude. Remember, magnitude is just the length or a distance of the vector. And so that's on my summary page that I have for you on the website. You can look at that as well. So so magnitude is anytime you're dealing with a length or a speed in a word problem or a distance. Those all point you back to magnitude. But anyway, for the one we're talking about right now, they're looking at an angle between two vectors. So we have a formula for that. So notice on this, they basically gave us a lot of this information in the given. You got the two magnitudes on bottom, you got the dot product on top, and that equals the cosine of the angle. So if we look at, go back to the worksheet here. So again, we had the two magnitudes on bottom, so 3 times 5 was our denominator. So we got the cosine of the angle. So we got 3 times 5. So we got their magnitudes on bottom. We have their dot product on top, and they already told us that result was 7. So they're basically just giving us all that information right there. So we know the cosine of the angle is 7 over 15. And so if we just do an inverse cosine of 7/15, that should give us the angle that we're looking for here. So if you do the inverse cosine of 7/15, that's where we get our angle of about 62.2 degrees. Remember, stick with our 3 sig figs on this stuff if you're rounding anything. So for the second part, it's the sketch triangle AOB. So we'll just kind of draw a random triangle here. We got AOB. And so for this one, the angle that we just came up with was the measure of angle O was at 62.2. So we got that one. We know the length of OA is 3. And the length of OB is 5. And so now they're asking us to find the length of vector AB. Right? Remember, magnitude means length. So they're asking us to find the length of that side right there. So obviously it's not a right triangle that we can tell. So we just be looking to use like either the law of sines or the law of cosines. In this case, we have to go with the cosine rule. So we have our missing side length over there. So we got our missing side on the other side. So I'm just plugging into the cosine rule at this point. So remember, the last part of that formula says cosine theta. So we already know that the cosine of theta is 7/15. Right? That was something we figured out right here in the first part of the problem. So I already know I can replace cosine theta with 7/15. Of course, you could put in there cosine 62.2, but the result for that is just going to be 7/15. So that's what we can just save ourselves a step by putting in what we already know. So anyway, that would be our setup. All you got to do is clean that up. So once you clean up the right side, just take the square root in order to get AB. So moving on to number 6. So number 6, we're given a vector U and a vector V. Find the value of K such that this scenario is perpendicular to v. So one thing you always want to remember about perpendicular vectors, and this is one of our main things. So perpendicular vectors, their dot product is always 0. So because remember, they form a right angle, and that takes you all the way back to the angle between them equaling 90 degrees. So anyway, all that goes back to that, but the main idea is that their dot product is 0. So based on that, I know that this times this should equal 0. So that's the whole key. Anytime you see perpendicular vectors, that's something we always want to get out of that statement. So if we plug in a little info here, so I'm just going to plug into what we have. So they're telling me to do u plus some scalar times v. So if we just kind of plug in the numbers for that, so we have vector u plus some scalar times v, which is negative 7, 5. So they're telling me that that times that should equal 0. So there's our given information right there, just kind of plugged in what we have. So now we're just solving this like any equation. So I'm going to let's do a little cleanup here within the brackets. We'll distribute the k so we can kind of line things up here. So within the brackets we're looking at, on top it's 2 plus negative 7k. Or obviously you could have just said 2 minus 7k. On bottom we're looking at 11 plus 5k. So again, we're doing that times the negative 7, 5. We know that equals 0 because they're perpendicular. So remember, for these guys, when you multiply, you just go straight across and then add the two results. So if I go straight across the top, so I'm doing negative 7 times those guys, so I'm going to distribute. So I got my negative 14 plus 49. Okay. So there's the top part. For the bottom part, I'm going to do the same thing with the 5. And remember, we always just add the two results. So I got my 5 times 11 plus my 25k. So I just set up that equation. Now we can simply just solve that for k. So pretty easy solve from here. Combine like terms. So what do we got here? We got our positive 41. So we're just going to bring that over to the other side. It becomes negative 41. Combine my two k's, so if I add those up, 74k. And then just divide that 74 over to the other side, and you got your value for k. Alright, moving on to number 8. See if I can bring this down here. Alright, give another kind of similar situation here. We're talking about perpendicular vectors again, looking for a value for k, and it tells us that p and q are mutually perpendicular. So obviously, again, like we just talked about, p times q equals 0 based on that statement right there. So and this one already kind of just gives us those two vectors. So this one's real similar to the last one, just even simpler. So I'm just going to, I'm going to go straight across and then add the results. So I know that negative 2 times 0, which is obviously 0, plus k times 1, which is k, plus 3 times k minus 8. So I know all those guys are going to add up to 0 since they are perpendicular. So just a little cleanup on that. So obviously if you distribute, you got your 3k minus 24. So 1k plus 3k is 4k. I'm going to take that negative 24 and add it over to the right. And then easy solve from there. We got our value for k. Obviously the main idea on that one is just recognizing that perpendicular tells you that their product is 0. Moving on to number 9. So again, a couple of new vectors for u and v. It tells us that their difference, u minus v, and then we got the magnitude bracket, so it's telling us to find the magnitude of their difference. for part A. So we would start with, just like any kind of PEMDAS order of operations, I'm going to start out with the interior part, so I'm going to do u minus v. So -2 minus 6 gives me that -8. And then 7 minus 1 gives me a 6. And so this one is now asking me to find the magnitude of that difference. So for magnitude, and this is something you have in the formula packet, if you forget how to do it, refer back to that. So it's just basically the square root of a squared plus b squared. So a squared would give me 64. B squared would give me 36. I'm taking the square root of that, so add those up. They add up to 100. Square root of 100 is 10. So there's their magnitude for part A. And then second part here, so something, so these are just constants, so these are just like scalars. So some number times u, so we got x times u, and then some scalar times vector v is going to give us the result of 0.22. So just kind of plugging in the information into that setup right there. We got two unknowns, so we're going to solve a system of equations here. So for the first system that I would write, if I go straight across the top, I got my -2x plus my 6y, and that's going to give me a 0. Going across the bottom, I got 7x plus y. It's going to give me that 22. So just going back to basic algebra here, solving a system of equations. You can use elimination or substitution, whatever works best for you. I think maybe what I would do on this one is just, I could do a little substitution. If I get y by itself, I would subtract that 7x over to here. So y equals 22 minus 7x. So that means I can now plug that into my other equation for y with some substitution. So replacing y with 22 minus 7x. And then now it's just some basic algebra to solve from there. So I know you guys can finish it off at that point, but just solve for x. And then once you get that answer for x, just go back to either one of those equations and plug it in for x so you can solve for y. This would probably be a great place to plug in your answer for x right there. Moving on. So going to number 10. All right. Sorry, let me try to get all that on there. Here we go. So we got positions A and B are given by those two position vectors right there. So find the distance between A and B. So remember, distance is length or magnitude. So we just do our magnitude on this one. So in this case, there's a couple different ways you can look at these with equations and how those vectors form AB. For me, the easiest way to see this is if I just want the distance between those two vectors, well, first of all, any vector, if I have vector AB, remember, you can always just do terminal minus initial to get the vector. So if I want vector AB, I just do B minus A to get it. So right here I have the vector for B, I have the vector for A. So if I just do B minus A, I get vector AB. So that's where I would start this one. So vector AB is just B minus A. So if I did my -3 minus 2, I get -5. And if I do 2 minus 7, I also get -5. So there is vector AB. But they don't just want the vector, they want the distance of that vector, or the length of that vector, which is its magnitude. So in this case, if I plug into my magnitude formula, so a little a squared plus b squared, and just taking the square root of that, so square root of 50. And as always, just check directions for how they want you to write the answer. If this is a question where you have a calculator handy, you can always plug that in and get your answer to 3 sig figs. If it's not a calculator question, or even if you just want to leave it in simplest radical form, you can. So let's see, 50 is 25 times 2, so 5 rad 2. So if the directions didn't say, you could leave it like this, you could leave it like this, or you could go 3 sig figs. Again, just always follow directions. For part B, find the size of the angle between the two vectors from OA to OB. So just looking for the angle between those two vectors to get angle AOB to the nearest tenth of a degree. So obviously we're going to use a calculator on this. So for this part, we just go back to that formula that we have in our formula packet for the angle between vectors. So we have let me show it to you real quick. There we go. So we have their dot product on top. So I got to do OA times OB on top. And then on the bottom, we have their the product of their magnitudes for the denominator part. So let's do some quick work on that. So on top, again, it's just the product of the two vectors. So I'm looking at -6 plus 14, which is 8. So that's how we're getting the numerator. On bottom, I have to do their magnitudes and then multiply their magnitudes together. So the magnitude of this one would be 2 squared plus 7 squared, and then the square root of that, I guess I'll just write it out. So 2 squared plus 7 squared. And then on the other one, the magnitude of that would be -3 squared plus 2 squared. So that's what we have for that. And remember that the setup on this is cosine of theta equals. So at the end of this, all that can go into your calculator, and then you just do an inverse cosine to get the angle that's being formed on those. So pretty easy solving from there. If you try to put all this into your calculator in one shot, just be careful because you got a lot going on down here. I would encourage you to do it in steps just to be safe. So I would do the denominator first, then I would start doing the whole setup in my calculator from there, just to play it safe. All right, moving on to number 13. All right, so again, a couple more vectors, u and v. First part, real simple, just add them together. So u plus v is just going to be -1 plus 6, which would be 5. -3 plus -9 would give you -12. So 5 -12 is their sum. So that would be the vector u plus v. So in the second part, find a unit vector perpendicular to u plus v. So remember, for a unit vector, that's where you find the magnitude, and then you multiply the vector by 1 over the magnitude. So that's something I did reference in my summary page that I have for you guys. So remember, that's how for a unit vector, that's anytime the magnitude is 1. And so to get this is the process that we do. So if I take the vector that I have right now and multiply it by 1 over its magnitude to each element within the vector, that's how we get the unit vector. And so this one is linking that to the idea of perpendicular vectors, which we know their product is 0. And then the other thing you want to remember with perpendicular vectors is two vectors are also perpendicular. If you just think of like when you have a slope, anytime you want a perpendicular slope, you just do the reciprocal and then you change the sign. So if I had, say, a slope of 2/3, perpendicular to that would be -3 over 2. So you do the reciprocal and change the sign. So a couple things going on with this one. So first of all, let's just find the unit vector first. So if I did the magnitude on this, so if I did my a squared plus b squared and do the square root of that, so I know that's going to come out to be 13. So there's our magnitude. So if I take my 1 over the magnitude and multiply it to each one of those, I would have 5 over 13 for the first part, and I would have -12 over 13 for the bottom element. So there's the unit vector. But remember, they were asking me to not only find a unit vector, but also to make it perpendicular to the original. So this is where I want to just change the order. So I'm just going to switch these guys around, but then I also have to change the sign. So I just need to change the sign of either term. So in this case, I'm just going to make when I switch them, I'm just going to change my negative to a positive. So that becomes 12/13 on top, and I got my 5/13 on bottom. So there's our unit vector, and then that's the one that would be perpendicular to that. So that's fulfilling their requirements that they were asking for. All right, moving on to number 19. There we go. So number 19 here. So we got the drawing on the right. We got kind of one piece of given information here that O is the middle of AD. So obviously that OA is equal to OD. So express each one in terms of OB and OC. So those are the guys going through the middle there. So first one, they want BC. So there's two ways you could look at that. One is just do the terminal minus the initial. So C minus B would give that to me. So OC minus OB. So that's one way you could write it. Or one way you could look at it. It's the only way to write it. So there's one way to look at it. The other way you could look at it is just the general equation. So remember that a common equation that we use for this stuff, if I want BC, I always know that OB plus BC equals OC. Right? You cut out the middle guy that they had in common. So where that one ends, that one begins. So it just forms from O to C. So that's where we get the OC. And then if I want to get BC by itself, right, I would just subtract this over to the other side. So to get BC by itself, I would just subtract the OB over to the right. And that's another way of getting that same answer. From O to D, so OD right here. So part B, so for OD, one thing to recognize is that wherever you have congruent parallel lines, those vectors are equal. So AD is the same as BC. So since I want it in terms of those guys, it's going to help me to recognize that from O to D, right, that's just half of vector AD, which must mean I can also do half of BC to get the same result. And I want it in terms of BC because that's what we've already done. So again, I know that half of AD is this, so that's the same as half of BC. So in this case, I can just take half of my last answer. So just taking half that last answer. So it's just half of BC. You can distribute the half, but you don't have to. So going on to the last part for DC. So see on this one, so DC, remember one way to write that is if we did OD plus DC, that would equal OC. Writing in terms of that always helps me kind of piece things together, put an equation together. So OD, so where that one ends, the next one begins. So from where OD ends, DC begins. And if you kind of cut out what they have in common, you are left with the vector from O to C. So that just always helps me put an equation together. Since I'm looking for DC, I can now get DC by itself in that equation. So if I take the OD and subtract it over to the other side, I have it in terms of this right now. So remember, I want this in terms of OB and OC. The OC we already have. OD we figured out in the last part of the question. So we came out with this for OD. So I can now just sub that in for OD. So I got my OC minus, and now I'm going to replace OD with this guy, which I'm just going to do a little distribution. I think it's going to help with all the negatives we got going on. So I had the half OC minus half OB. So I can just sub that in. And then now obviously I want to do a little cleanup on that. Do a little simplifying here on the right side. So for DC, if I distribute the negative, so I'm looking at OC minus half of OC. Well, 1 minus a half is a half. So I get the half OC. And then that negative distributed over here, so that became plus half OB. And so that I would just leave my answer like that. You could factor out the 1/2, but certainly don't have to. So moving on, number 20. There we go. So we got vectors I and j are unit vectors along the x-axis, y-axis. So vectors, so they give us some information for u in terms of I and j, and then same thing for v in terms of I and j. So first things first, find u plus 3v in terms of I and j. So for that first part, just really subbing in the information. So if I plug a u in for that guy, so and you don't have to write these, at least when you're doing the work. If it helps, you can put them in column form if it helps, and then put them back into terms I and j if you need to, whatever makes sense for you for getting the answer. So plus 3j. So I'm plugging that in for u. Plus 3 times v. So 4i plus 7j. So just do a little cleanup on that. That's going to be a 12i and negative 5i. That's going to give me 7i. And then I got my 21j and 3j, which is 24j. And so there's all we get for that one, just by plugging in. Alright, so a little tricky question on the last one here, but definitely one we need to know. So vector w, so now we're just finding some other vector that has the same direction as the answer we just got. So it has the same direction as this. And remember, all that means is they're parallel if they have the same direction. So parallel vectors are equal vectors or any scalar of that. So if I did 1 times this, I get that vector, which means 7i plus 24j is parallel to itself because it has a scalar of 1. I could have a scalar of 2 and say 14i plus 48j is parallel to that one because it has a scalar of 2. Any scalar you could use is parallel to this one. So keep that idea. So I'm looking to find any scalar times that is going to get me my answer. The question is what's the scalar? Like, how do I figure out, is it 1 times this? Is it 2 times this? Is it 3 times this? We need to know what that scalar is so that I can create a magnitude of 100. If you look at the original vector that we have, the 7 and the 24, what is the magnitude of that? So if we kind of look at what the magnitude of that one is, so if you did the square root of 7 squared plus 24 squared, you would figure out that the magnitude of that is 25. Well, if I need a magnitude of 100, right, that means it needs to be 4 times bigger in order to get that. So essentially what we're doing algebraically is I'm taking the vector that I need over the vector that I already have to figure out the scalar. So I figured out that the scalar was 4, so now I can just plug that in for k as my scalar and distribute. So 4 times 7 and 4 times 24 is going to get me my vector. And again, I know it's parallel to this one simply because it's just a scalar multiple of what I already started with, so I know they're parallel. In other words, they run the same direction. And then you just kind of want to remember the process that we took in order to figure out what the scalar was that was needed to get one that has a magnitude of 100. So moving on to 21. So a couple new vectors. So u, v are given. They give us the information in terms of I and j for u and v. So finding scalars such that fits this scenario. So this will be pretty simple. We just got to plug in the information that we have to figure that out. So if I take u plus v and plug it in for that, so I think we can probably do that part in our head. So if I did u plus v, so negative 5 plus 4 is negative 1. As far as the j term, so 3 plus 7 is 10. So replacing that for the u plus v, and they're telling me that's going to be equal to my 30i plus 2 minus bj. So there's our setup if we just kind of plug in the information that we have. And so I think this will make more sense if I distribute the a. So let me kind of show you where this is headed. So if I did a times negative 1j, or sorry, negative 1i, so there's our first term, plus a times 10j is going to give me the information on the right. So for this part, just look at the components individually to see what they represent. I want my first term to equal 30i, and I want my second term to equal 2 minus b times j. So if I just kind of set the components equal to each other, so a times negative 1i is going to equal 30i, right? So I just need those guys to be equal on left and right. So that must mean that if I divide my negative 1i over, right, that gives me a. So in this case, I need a to be negative 30 in order for that statement to be true. So we're just kind of solving algebraically there for a. So I'm just like dividing this over to the other side. So I'm just dividing both sides by negative 1 in order to figure out what a is. And then on the second part, right, I want these two guys, the j terms, to be equal to each other. But I can now replace a with negative 30. So I got negative 30 times 10, which is negative 300 j. And on the right side, I got the 2 minus b times j. So again, I just want the two terms to be equal, which means my negative 300 needs to equal 2 minus b. And so now we can just solve that for b. So if I wanted to get b by itself, so subtract the 2 and then divide by negative 1, should give us 302 for b. All right, last couple here. Now moving on to 22. So find a vector equation. These are always real popular test questions, so definitely need to know how to do these. So pass us through those 2 points. Give your answer in kind of that vector notation format for the equation, where t is an element of the real number system. So here we go. So remember, just relate this to like the equation of a line, like y equals mx plus b, where b is just a point. So either one of those could act as our point. So either one of those can go in for p. That's our point. D is like their, well, the easiest way to remember that would be their difference. But d is the direction vector. So we're going like from here to here. So to get the direction, I just subtract backwards to get that direction vector. So I'm just going to do this minus this in order to get the direction vector. And then t is t. We just leave that. Remember, that's like y equals mx plus b. So d is like the m, like the slope in that scenario. So want to get their difference. So if I did negative 6 minus 10, sorry, negative 6 minus negative 10, it's like saying negative 6 plus 10, which is 4. So there's like the y component. And then on the x's, I got 3 minus negative 2, which is 5. So there's like my x component. So there's our direction vector, is that 5, 4. So for p, just pick a point. It doesn't matter which one you use, just pick one. So negative 2, negative 10, I'm just going to pick the first one. And then you got t is t, that just stays. And then our direction vector, we found their difference was 5, 4. And that's all we got to do for that one. Do write it as the equation. Anytime they specifically want it in a form, you need to make sure it's in that form. So you got to say r equals this. It's real particular about the way we write that. So anytime you're writing the equation of a vector, you need to start out with a vector variable to get that full points for that answer. So moving on to the last one. So looking at number 27. All right, so this is the one that's, these can be a little bit lengthier, but these are really important that we know how to do these. These are always popular test questions. I've seen these on several IB tests. So we're given two equations of two different vectors, r1 and r2 are our two vectors. And we're looking for a point of intersection for these two guys. Just like finding the intersection of two lines, same thing, we're just finding the intersection of these two vectors. So to get that point, we first need to figure out one of our two variables. So we have our t right here, and then we have one of our Greek letters right there. I want to say that's lambda, but I'm not 100%. But anyway, so got to find out that point of intersection for these guys. So one thing we have to do is find out one of those two variables. You can find them both, but we need at least one of those in order to get our point of intersection. One thing you got to recognize is once you find one of those two variables, recognize that that's not your answer. We're using that to get our answer. So really important that you understand that part of it. You got to take the extra step. So just need to solve like a system of equations here. So if I pick start out with the top components, so -3 plus lambda 3. I'm going to make this easy on myself. I'm just going to call that an x, just to make life a little simpler. So -3 plus 3x for that equation. And then on the bottom equation, I could say 1 plus 1x. I'm going to match those up with the guys on the right. So remember, I'm finding out where they intersect, which is what allows me to set them equal to each other. So on the right side, I got the 2 minus 4t. That goes with the top guy. The bottom guy is the 7 plus 3t. So we got our two variables. Again, I only need one of them to get me to my answer. Unless they specifically ask me to identify what x and t are and then get the point of intersection, but they didn't ask that, so I only need one of them to get to my answer. So we're just solving like a basic system of equations, so substitution or elimination, whichever one works best for you. One way you could solve this would be with elimination. So I did substitution earlier on this worksheet, so I'll do this one with elimination. If I multiply my bottom equation by -3, that would set this up for elimination. So I'm going to multiply my bottom equation by -3 to set this one up. So it gives me a -3 as my first term, minus 3x equals -21 minus 9t. So there's my new equation. So ignore him for a minute. So remember, all elimination does is just says add those two equations together, and one of your variables should get eliminated. In this case, it'll be my x's. So if I add those together, I get -6. Those guys get eliminated. Right here, I got a -19 and a -13t. So you didn't have to go this route. You could have done substitution, but whatever works for you. So if I add my 19 over and then divide by -13, so if I do all that, I come out with t being -1. You could plug that back in to get your other variable if you needed it, but at this point we don't need it. All I need to do now to get my point of intersection, remember it's just a point, so I just need to take this and plug it back in order to get the point. So if I put a -1 right there, then I have -1 times -4 plus 2, or I could say 2 plus -1 times -4. It's going to get me the top component. So 2 plus 4 is 6. And for the bottom component, 7 plus -1 times 3 is 4. So there's my bottom component, and that's my answer. It's that 6, 4. So remember, they didn't want that scalar multiple, right? They wanted the point of intersection, so I needed the full component form of that point. So always make sure that you take your answer and plug it back in to get that. If you would have solved for x and you plugged your answer in for x and did the same process, you would get the same answer. So one thing you could do if you had extra time on a test is do that to check and make sure that you're also getting 6, 4 just to confirm your answer is correct. So that's an option if you have time. But you may run into a question anyway that asks you for the variables x and t or lambda t or whatever the two variables are. So they could ask you to find those first and then get the point of intersection. So they might ask you it in 2 steps. or they could do what this one did, which is just one step of just get the point of intersection, which is what we did. So that's the end of that one.